today we start with an industry track run by Kaspersky. Then we have a technical sessions. We have a keynote by Christoph Parr. We have afternoon technical sessions, then business meeting and social activities. The meetings and the keynotes and the sessions are recorded. And now it's my pleasure to introduce to you Jochen Michels, who will moderate the Kaspersky session. Jochen Michels is Head of Public Affairs, Europe at global cybersecurity company Kaspersky. In this role, Jochen is responsible for Kaspersky's governmental affairs work at EU level and across the member states. He studied political science, public law, and history at Helmut Schmidt University in Germany. And he holds an additional degree in PR and public affairs. For more than 20 years, Jochen has been working in various management positions in the ICT industry, both at global players like Fujitsu as well as SMEs. He was and is a member in several working groups, currently of the Working Group Security Policy and Public Policy of Germany's Digital Association, Bitkom. He contributes to platforms of industry organizations like the platform Industrie 4.0, public-private partnerships, and think tanks. In addition to that, he was one of the authors of the future study, Mobility Fulfillment System on the Future of Mobility 2025. From 2011 to 2018, he contributed to the work of Platform 6 of the Digital Summit of Germany's federal government. And previously, he was an army officer with the Federal Armed Forces of Germany. So now it's my pleasure to give over to Jochen, and we are looking forward to the panel with Kaspersky. Jochen, the stage is yours.
Yes, thank you very much, Haya, and congratulations. Congratulations on that very important and impressive conference with an outstanding program, outstanding topics, and outstanding speakers. And I hope we can contribute as Kaspersky to that. Let me give a little bit of brief introduction to the topic. Why have we chosen the topic cyber immunity and Kaspersky OS? That is because we think a paradigm shift is necessary. We think that the current cybersecurity solution landscape is much too complicated as well as too fragmented. And to say it wraps around IT solutions and infrastructures. And because of that, we at Kaspersky and the colleagues who will give the speeches and will discuss with you, we have developed a cyber immune methodology, and that focus on both security and also security by design approach. And I have the honor to introduce you to the main speaker of our industry session. That is Maxim Donsov. He is security analyst group manager in our so-called secure platform development. And he and his team is responsible for the development and implementation of that new methodology called cyber immunity. And our aim is to bring a new level of security based on Kaspersky OS. Yes, Maxim and his team, he and his team analyzes threats, vulnerabilities of each cyber immune solution and helps the product team to design secure by design software architecture. He has graduated from the Bauman Moscow State Technological University with a Master of Computer-Aided Manufacturing System with a honor degree diploma. And you can imagine that his focus topic is Kaspersky OS and cybersecurity systems development. The second speaker from Kaspersky who will attend in the discussion and also in the chat and will give answers and so on is Sergey Rogachev. He is head of our secure platform development. He's a very experienced scientist in developing operation systems and hypervisors. And he was, and his team was responsible for developing that Kaspersky OS microkernel. Before joining Kaspersky, Sergey worked for Samsung's Moscow Research Center, where he developed the local branch of the Linux kernel used in smart TVs and smartphones. Sergey is passionate about compact, minimalistic systems with orthogonal interfaces. And last but not least, hello to Evgenia Ponomareva. She is Senior Business Development Manager in our new established Kaspersky OS operational system team. She is development for the launch of our different solutions and products based on Kaspersky OS on a global level, and is experienced in different industry, in automotive industry, IoT, and so forth. And now I would like to hand over to my colleague Maxime, who will give an overview on the principles of cyber immunity, and will also give some examples and best practices where cyber immunity and Kaspersky OS can be used. Maxime, the stage is yours.
Thank you very much, Johan. Thank you for the invitation. Hi, everyone. Let me just start screen sharing. Okay. So once again, my name is Maxim Dontsov. I'm head of Kaspersky OS security analysis team. And I would like to share with you some of our ideas about our new approach called cyber immunity, which is based on Kaspersky OS. So everybody knows that safety is one of the most important humans need. However, in the modern cyber age, not only human beings need protection. We are surrounded by billions of smart devices that collect various data, communicate with cloud infrastructure, and perform different tasks, making our life more and more comfortable. But the more complicated this little world becomes, the more threats do appear and try to turn Internet of Things into Internet of Threats. Here in Kaspersky, we're working on various solutions to withstand these threats and make IoT world more secure. But unfortunately, our anti-malware researchers every day detect more and more unique samples of malware, specially designed for various embedded systems. Therefore, about 10 years ago, we started to think how to improve this frightening trend and summarized industry challenges. We realized that it becomes increasingly difficult to protect embedded systems through ordinary solutions like, for example, antivirus, IDS, DPI, and so on, because there are three huge problems. The first one is obvious. Constant growth of malware activity makes us to develop new security features and security products. Second is our life becomes much faster. Product development lifecycle becomes shorter. That means we have to implement these security features as fast as possible, design new solutions, release more products, and then support them, detect and fix more and more vulnerabilities. And the third one is a question of trust. Each solution should pass through various assurance procedures to achieve certificates before anyone on the market would buy it and install. These procedures become more and more complicated over time because regulators add new requirements and standards. So if we keep on adding security around the embedded systems, we think that one day we may lose this battle with threats. So we put all the suggestions, and these suggestions led us to the conclusion that the only way to dramatically change the situation and protect embedded systems is to make them secure by design. So security, safety should become an inherent property of any embedded system. And therefore, we need an approach capable to provide protection from already known and new threats, be convenient, especially for agile development, and simplify software assurance procedures by making solutions more transparent for any kind of evaluator. We want to create new generations of solutions capable to withstand not only known but even new cyber attacks, and we call these solutions cyber immune systems. And system becomes cyber immune not because it's based on Kaspersky OS or any other technology, but because it has been created using certain methodology. Why methodology is so important is if we look at any software development life cycle, even at security dedicated like SDLC, in fact, we won't find much about security. These processes say absolutely nothing about defining a secure solution. They don't say what exactly should be done to develop a secure solution. They only contain indirect recommendations like testing, fuzzing, and so on. And finally, when we develop a solution according to these processes, they will not help us to pass through assurance procedures. But nevertheless, they are very good industry frameworks. So we decided to take them as a basement for our process, and we slightly improved them by adding some very specific security features. Let's go step by step and see how product gains cyber immunity. First, we need to define a security scope. Each cyber immune system should have security objectives that are high-level security requirements. These objectives must be achieved in all possible scenarios under predefined security assumptions. Security assumption is a requirement from cyber immune system to a high-level system or the environment. And this security assumption simplifies security objective achievement. For example, this is IoT gateway. It collects data from various IoT devices and sends them this data to the cloud. We can have two security objectives, for example, provide integrity and confidentiality of communication channel between the device and the cloud, and isolate internal network from external. And developer can also add a security assumption that attacker has no physical access to the device. That means this gateway will not have a protection from these kind of attacks. That means no secure boot, no disk and memory encryption, but this assumption will reduce cost of the device. And because we stated security objectives and security assumptions, client will exactly know from what kind of attacks this device will protect him and what kind of environment should be provided to this gateway to mitigate other possible scenarios. Now we can start with the architecture design. Each software product consists of different components. Some of them trusted, have a direct influence on security goals, like, for example, crypto functions provider or certificate storage. Some components untrusted, like, for example, graphic user interface, do not. We call a component trusted because we have to trust it, otherwise security objective achievement cannot be assured. The less trusted components we have, the less trusted code base is, which means less attack surface, and as a result, more protection and less chances to for attacker to exploit any kind of vulnerabilities. But unfortunately, trusted components have to communicate with untrusted, and attacker still has possibility to compromise trusted code using vulnerability in untrusted component. So to prevent these cases, we need to isolate trusted components from untrusted and control all interactions between them. Thereby, trusted code can operate in a secure environment and reduce risk of vulnerability exploration. And all these principles were in fact stated in a very great approach called MILES, or multiple independent levels of security. And these ideas of isolation and control are fundamental principles of MILES, and we decided to use it as a basement for our platform, Kaspersky OS. So Kaspersky OS has a microkernel that isolates components in different security domains and a special entity called security monitor that applies policies to all communications between domains. All code, no matter what kind of it is, business logic application or system driver, operates with minimal privileges in a dedicated CPU memory zone. If attacker somehow manages to compromise a component, he won't get an access to another component's code immediately. And it would be extremely difficult to spread the attack on the kernel because it provides only a few set of functions and has a very small attack surface. But let's go back to the business logic and the architecture of the device. Most of products start their way to cybersecurity, to cyber immunity, with a very simple architecture. For example, this one. In fact, it meets all principles discussed before. There are three isolated entities on this diagram for code execution. All communications are in fact transparent, and security policies can be implemented easily. But if we look deeper at this architecture is not secure, it's very vulnerable. And let's discuss why. First, let's discuss who is our attacker. We consider that attacker is highly qualified. He has significant capabilities, such as, for example, zero-day exploits. And he also might wait a couple of years after product release and use new unique tools and techniques to compromise device and breach through our defense. That means everything that can be hacked will be hacked. And to ensure achievement of security objectives, we need to detect and remove the root cause of probable failures, insecure states. To do this, we suggest perform threat modeling for each component. What happens if attacker compromises particular component? Will it result in failing to achieve security objective? If the answer is yes, we need to take countermeasures. In this case, if we go step by step, you can see that, for example, IO subsystem communicates with the internet, and attacker can compromise it easily because it has a huge code base. It consists of a file system of different drivers, and finding a vulnerability and exploiting it is just a question of time. That's why we can take a countermeasure. We can decompose the subsystem into two independent. One of these subsystems will operate only in internal network and another in external. If somehow when the attacker gets an access, compromises external subsystem, he wouldn't get an access instantly to internal one. By this principle, we can also improve work with SD card because this card is accessible from both internal and external. We can also decompose these subsystems into network and file subsystems. Now an access to the file storage is granted to only one component isolated from the network. Drivers, they are also vulnerable and should be isolated from the network stack. That means if we go step by step and keep on moving and decomposing entities in this way, finally we will achieve an architecture capable to withstand most of attacks because trusted components have very little attack surface. Also, we'll be able to prove this statement to any evaluator because all possible interactions between domains are transparent. Like in this example, there are only 3 possible attack vectors on internal network, and even if attacker manages to compromise all components on the right side of the diagram, he won't easily get an access to the internal. And all these attack vectors, even in this example, can be managed by security policies. And the next step of our methodology is designing and development of security policies. They are being developed along with the business logic. And to do this, we have a very nice approach. We have a Kaspersky security system, which is based on a very nice approach called Flask. We have a special purpose entity called security monitor that holds all security policies. When one component tries to send a message to another, he can only do it by using a predefined type channel. Each message comes through kernel, and the kernel sends a request to the security monitor. Security monitor calculates verdict based on different security policies and returns result to the kernel. If this verdict is positive, message passes. If not, kernel rejects this communication attempt. This approach allows us separating policies from business logic and allows us to design unique policies for every unique solution. Also, policies have been designed using high-level abstract policy definition language that already supports many formal models of access control, such as mandatory access control, mandatory integrity, role-based, and so on. And then this high-level language translates into C code that can pass through any assurance procedures and then compiles into security monitor. Business logic can be also developed in a convenient way because Kaspersky OS is POSIX compatible. That means if you have a source code on a Unix platform, it can be ported to Kaspersky OS. So you won't have to completely redevelop existing components and solutions. And finally, testing and verification. We have several independent verification procedures for each cyber immune solution. First, security analysts like me and my colleagues that are independent from the development team, we need to verify that architecture meets secure by design requirements. Then security policies are also being developed according to the architecture by independent team. And when they applied, they ensure that components can only interact as it was designed before. Also, all components should get tested according to their role and their attack surface. And finally, we require independent penetration testing for every solution based on Kaspersky OS. Kaspersky also has launched Global Transparency Initiative. In transparency centers all over the world, trusted partners, state agencies, regulators can examine source code of our solutions. And also Kaspersky OS products will be available in these centers soon. We agree with the second statement about ways of constructing software design. So complicated design with no obvious deficiencies is worse than simple one with obviously no deficiencies. Also, we believe that transparency and secure by design is what industry needs to withstand these cyber attacks in a modern age. And we hope so do you. Thank you.
Yes, thank you very much, Maxim, for that presentation. I just want to ask all the attendees, do you have questions to Maxim or additional remarks? And also to the Kaspersky colleagues, have you additional remarks to that speech? You can both use the chat for questions, and you can also ask the questions orally. Okay, perhaps if no questions are there currently, let me start with one question to both Maxim, but also to Evgenia. Maxim, you spoke at the very beginning and also during the speech about IoT and so forth and different industries. From your experience, from the technical point of view, and Evgenia also from the market perspective, what are the first industries where cyber immune solutions may be implemented? And you can inform the attendees about some first best practice, pilot projects, and so forth?
Well, I think Evgenia will answer much better than I do. Yeah. I'll support her if required.
Okay.
Yes, hello, colleagues. Actually, Kaspersky OS is the basis right now for several directions in our department. So the first direction was for IoT infrastructure, and here we already have several projects in Russia. It's in smart cities, in public sector, and in transportation. The second very important direction is automotive industry, because we see how this industry is changing now. New approaches for cybersecurity required in case of changing of E2E architecture and upcoming cybersecurity regulation. And we develop a dedicated solution for automotive industry. The next type of solutions which we develop now in our business unit, it's for remote workspace solutions, because in case of latest 2 years, it's high demand from the market to secure workspaces of people who are not in the office. For sure, we work under the new directions for the industry systems, actually, it's just the first steps. But what is very important? So Kaspersky OS is dedicated, a special dedicated operating system for embedded connected systems, where we can fix the scenario of usage of the device or the system, because as Maxim mentioned, for each system we analyze potential threats. We build the dedicated policies inside our system to protect it.
Thank you very much, Evgenia, for giving that examples on best practices and so forth. I think we can further discuss on that a little bit later, as we have the first question in the chat. It's by Yasin Megdad. I hope I've pronounced the name correctly. Yasin, do you want to ask the question orally, or should I raise the question? Okay, I can go ahead. Okay. Given the security features of Kaspersky OS that consists of blocking unauthorized activities, can the Kaspersky OS detect unexpected malicious activities, such as 0 days? Perhaps Maxim or Sergey?
Yeah, I can answer this question. Thank you. The idea of cyber immune approach is not to just to detect these unexpected activities. So our task is to design an architecture that can operate when we already know that there are 0 days inside the architecture. So we go step by step and see how this system operates. If there are any possible scenarios when something can go wrong. For example, we have a very nice example of a traffic light that controls traffic on the crossroads. And there is a insecure state when both directions have a green light on them. And no matter how attacker can cause this state, if it's because there is a 0-day exploit in, I don't know, in graphic user interface, or there is a problem somewhere in protocol, no matter where, we just state that this state is insecure and the system should detect all attempts to transfer to this insecure state and block this insecure state. That means when the system is released, when it starts to operate, even if you find any kind of 0-day, the root cause of the problem, possibility to transfer the system into this insecure state will be blocked. And Kaspersky OS has a Kaspersky security system that has possibility to block any messages that don't meet security policy requirements. First kind of policies is the message type doesn't meet predefined typed description. For example, you say that two entities, entity A and entity B, can communicate only with, I don't know, two integers and one Boolean, and that's all. If attacker somehow manages to compromise entity A and then tries to fuzz, for example, entity B by sending huge amount of data, the Kaspersky security system will simply block this because it's not allowed to send, for example, binary data through this channel. So we can design a solution and prove that it's secure because attacker will only have a very limited pre-designed, predefined channels from one entity to another. And it really simplifies assurance for a system like this.
Yes, thank you very much, Maxim. I would like, Evgenia, if it's okay with you, I would like to ask an additional question with regard to the different industries you mentioned where Kaspersky OS can be used or where good use cases are there. You spoke about automotive, and automotive is in particular for Europe and also for Germany, a very important market, both the car manufacturers, but also the car suppliers, the suppliers for the car manufacturers. What are very concrete best practices and use cases for Kaspersky OS? Can you give a brief overview on that?
Yes, for sure. Actually, Germany is major market for us, for our automotive direction. We already have the reference case with German company, which are based in Regensburg, AVL Software and Functions. Together with AVL, we developed ADAS control unit. So we used our Kaspersky operating system and our middleware based on AutoSAR adaptive standard. So it's this standard is supported by main OEMs and tiers like Conti, Bosch, like BMW, Volkswagen, and we integrated our software with their hardware platform and application, ADAS application. So this is a real prototype. This is it was very interesting project for us. So it's still ongoing because here we design our solution based on the future architecture of the electronics and based on the upcoming regulation where we have requirements about secure by design system. So actually upcoming regulation for the cybersecurity includes requirements to make the analysis of potential threats and vulnerabilities, and only after this analysis design the system, secure by design system. So we used all this approach during this project.
Yes, thank you very much. Very interesting. There is another question in the chat, not so much in regard with regard to Kaspersky OS and cyber immunity. It's more about the global transparency initiative launched by Kaspersky. About the global transparency initiative, I found this information and then the link to our transparency centers. I read about relocation of infrastructure is a main point in this initiative. What other activities in technical meanings you follow to provide transparency and accountability? Perhaps also I'm a moderator and I should not give content and impulses. I suggest that I answer that question because I work closely together with the colleagues in our CEO office and the manager who is responsible for that global transparency initiative. First of all, thank you very much for that very interesting question. The global transparency has, one can say, 4 or 5 pillars. One pillar is that we have established in different regions of the world, starting with Europe, in Switzerland, and also in Spain, so-called transparency centers. And that centers are locations where customers, regulators, partners, researchers can do source code reviews of our software. So that is one very important step of increasing transparency and accountability. A second step is that the data we receive by our customers on malicious source code. So no personal data, but of malicious code sent to us. The data center is relocated to Switzerland. So for European users and also other regions in the world, that data is stored and is processed in Switzerland. That is a second pillar of that global transparency initiative. The third pillar is that we work together with a lot of external stakeholders and partners to get reviews on our practices with regard to the software development processes. We have passed, for example, the SOC 2 audit conducted by one of the four most important audit and consulting companies in worldwide. We have also the certification, the ISO certification 27001. So that third-party assessment, also with regard to legislation in Russia, for example, we asked a professor, a European professor from Sweden, to do a research on the legislation we have in Russia with regard to our obligations to work together with the state and so forth. So that was the third pillar. The fourth pillar is a so-called cyber capacity program, a worldwide cyber capacity program. And we think, or we experience that our customers, and not only customers, also regulators and public authorities, have different degrees of maturity when it comes to skills in cybersecurity. And we think it's important to, yes, improve skills, to offer a lot of trainings and so forth. And because of that, we have offered that special cyber capacity programs to enable regulators, academic institutions, universities to do such source code reviews, for example, not only with regard to Kaspersky software, but with regard to other software too. So fourth pillar was that cyber capacity program. And the fifth pillar is we have increased our cooperation with the security community, with the community of the researchers. And we have extended our so-called bug bounty program. So if someone finds faults in our software, we have a special bug bounty program, and researchers finding bugs in our software can get up to $100,000 for that findings. That is not only from a technical point of view, also from the point of view of education, training, and so forth. That are the 5 pillars of the Global Transparency Initiative. I do not know whether Evgenia, Maxime, or Sergey, if you want to add some points.
No, nothing to add.
Okay, thank you very much. Yes. Perhaps one further questions to Maxime and Sergey. Sergey, sorry. Maxime, in your speech, you mentioned that we have started that development. I think it was 10 years ago or so a quite long time, or 5 years ago. I know you was not with Kaspersky during that time, but perhaps you can give an information and an idea about what were the reasons for that new step, and what were the main steps on that road to develop that cyber immune operating system?
Yeah, thank you for the question. Yeah, the development even started like 12 years ago. Yeah, it was even more. Well, 12 years ago, it was a very small team. There was a future technologies department in Kaspersky, and my colleagues started to analyze the trends of modern cyber age, and they started to find out that it's really becoming more and more difficult to apply security above solutions. And they started to look into different articles. They started to analyze Mills approach, Flask, and so on. So they, in fact, they started to create an internal killer of all Kaspersky products, like to replace antivirus, to replace all other modern solutions, to provide the security. There were several, in fact, milestones. We still have a very nice secure hypervisor. This microkernel, we have Kaspersky security system, which in fact is a huge framework that contains of many components. And the team steadily grew up. And like about 3 years ago, we started to design not just proof of concepts, but we started to develop this methodology. And like about 3 years ago, we started to invade the market. There were also previous, these activities were like 5 maybe years ago, but not so, I would say, fundamental. And now we have an approach, we have a methodology, we have lots of clients. I think Evgeny can prove this. And we are looking forward for new demands of the market, for new features to be developed.
Thank you for the perfect retrospective.
Yes, thank you. Thank you very much. As you already slightly handed over to Evgenia, I would like to ask one further question to Evgenia when it comes to the different customer groups and so forth. In the first answer you gave, you spoke also about smart city projects we have in Russia, for example, in Moscow. Can you describe that projects a little bit and make clear what was the situation before Kaspersky US and our cyber immunity solution was implemented? Was what the demand of that customer, and what is now the benefit and the value for the customer?
Yeah, actually, I would like to start from very interesting project which we had last year. It was with the Russian railways. So it was the demand from the customer that they need to protect connection to the rail heating system. Because as you know, Russia is a very cold country, and it's very important to protect infrastructure, railway infrastructure. And here we use a special heating switching system, which heats the switches during the winter. And now Russian railways, they have very big project of the digitalization of infrastructure, and they propose the idea to use our IoT gateway to protect communication between heating system and monitoring center, because before this heating system was working all the time. So during the night, during the day, no matter of temperature. So now it's a digital system, and we did the pilot zone to test this scenario. So our IoT gateway is implemented near the heating system, and it sends information to the monitoring center of Russian railways. So this is the case number one. The case number two was for smart building. We have not very big city, the city is Orenburg, and the administration of the city decided to add to some smart building systems. And during this project, we also implemented our IoT gateway inside the building and collect data from water meters, energy meters, from temperature sensors, and then also send the information to the monitoring center by a secure channel. Because before it was the problem that main information was sent through the public networks. But the system also, it's possible not only to monitor the devices inside the smart building, it's also possible to switch off, for example, the heating system during the winter. And to avoid such type of situation, we also protect the channel between the systems inside the building and the monitoring center. So it's two biggest cases. Right now, we also have the case with cloud video surveillance system, and we did this project together with Axis. So it's a big producer of video surveillance systems. Here we also protected connection between the video cameras and monitoring center.
Thank you very much, Evgenia, for that clarification and also the examples. I think in particular interesting also the use case or the use case of Russian railway, because I think transportation is also a very important market when it comes to such cyber immune solutions. We have another question in the chat. It's by Marcel Vinandi. Which technical topics or features are seen as very difficult and future work, perhaps where the research community can help? I think it's to Sergey and Maxime.
Yes, let me answer this question. There are many topics that require more research, and we face many problems. For example, we classify our components to two categories: trusted and untrusted. And as to trusted components, we have to trust them. So we need to somehow check that these components don't have any vulnerabilities inside of them. So we need to formally prove some of their properties. And this is a huge field for formal methods, for formal specification, formal verification, very difficult sphere. And also, you know that we have analytic departments where security guys, security analytics like Maxime, assess our architectures, and we want to prove that there is a correspondence between high-level architecture schemes and our security policies that we implement in our Kaspersky security system. Right now we have no automated method to prove this correspondence between policies and architecture. So maybe this is a topic for future research, and we see some possibilities to use model finders and model provers, and maybe SMT, SAT solvers. That's all.
Yes, thank you very much, Sergey, for that outlook and the view into the future and what is needed, in particular when it comes to future research and where the scientific community could be involved. Maxime, do you want to add something? Have you, yes, some other points?
No, I have nothing to add. Sergey's answer was perfect.
Okay, thank you very much. There is a further question in the chat. It's from Joachim Biskup. At first glance, the notion of cyber immunity appears to be a nice keyword. But how do you distinguish the notion of security as defined traditionally and the notion of immunity precisely in some formal terms?
Okay, let me try to answer this question. First of all, really thank you for this question very much, because in fact you you ask exactly what we are doing right now. Right now, there is a federal institution in Russia called FSTEC, Federal Service for Export Control. It's a regulator, one of the top regulators in cybersecurity in Russia. And we started work with them. They asked us to design new improvements to cybersecurity standards here in Russia, based on cyber immune approach. And we have like 3 years plan to design, to study, first of all, current standards, current articles about different approaches, and formalize this approach, the cyber immune approach. And right now we are trying to formalize the term, what does cyber immunity mean? What is secure by design? And what is cyber immune approach in a formal way? And unfortunately, I can't give you an exact answer what immunity or secure by design mean, because we have too much variance, and I think maybe it will take like 1 year before we can publish results. But the main idea is secure by design is the way for achievement security, which aided to simplify security assurance procedure.
Jochen, you are muted.
So I have understood that I have to wait for a precise answer. But security by design is I guess security by design is something different from immunity. Immunity seems to be directed towards thinking, first of all, in terms of attacks. But I'm not sure. What do you really have in mind? And I have understood that I have to wait. Thank you.
Yeah, you have to wait for for precise terms, unfortunately. But immunity means possibility to prevent attacks, to stay out of insecure states, and this is the way to achieve security, because security is the system that can operate only as it was designed, and immunity is one of these ways. But really, I can't give you an exact answer right now about meaning of these words.
Yes, first of all, thank you very much for the question, and Maxime, thank you for that answer. I think that is a very difficult question and a very good question. And our CEO Eugene is not here, but what he always says when it comes to cyber immunity, what means cyber immunity? To make it very simple and clear. Sometimes he says, or most times in his speeches, he says, okay, the solution is cyber immune if the costs for an attacker are higher than the potential gain. And that is a little bit the same as it is with immunity in the medical sphere when it comes to the pandemic and so forth. So immunity means that we are so much prepared, our body is so much prepared that we do not get an infection because we can fight against that. And when it comes to cyber immunity in the IoT sphere and other areas, one can answer that question in a very easy way, but there is no easy answer. The costs of an attack are higher than the potential gain, and then there is no, there is no value for the cyber criminal, for the attacker to attack such a solution. Okay, we have 4 minutes until the end of that session. So in case there is one further question, you have one chance to ask that question. In case there is no further question, I would like to thank first of all Maxim and the further colleagues from Kaspersky, Sergey, Evgenia. Thank you very much for your speech, the discussion we had, the different informations. And I would like to hand over back to Haya and again say thank you to you to give up that platform. It was very interesting for us and very important to give an overview on that new methodology, on that new concept, because we think that, as I said it at the very beginning, a mind change is necessary when it comes to cybersecurity, and our answer to that is also, it is difficult to explain. As we have experience doing that discussion, our answer is cyber immunity. So thank you very much. And also for all the attendees for your interesting questions. And we are happy to further discuss with you. Reach out to us. Visit the website I posted in the chat. Thank you very much. And Haya, you have the last words.
So first of all, let me thank Kaspersky for being a sponsor of ESORICS 2021. Thanks to you guys very much for helping us and making ESORICS what it is today. Thank you, Maxim. Thank you, Evgenia. Thank you, Sergey and Johan. So then we are closing now and we are moving to the technical sessions. After the technical sessions, we have a keynote by Christoph Parr. See you in a second in the technical sessions, everyone.
Thank you. Bye-bye.
Thank you very much. Goodbye.
Bye. Thank you very much.